Hello and welcome. My name is Darren Tidwell and I'm an SE here at HPE Aruba Networking. I want to talk to you today about secure third-party access. Regardless of what industry you're in, you're going to probably either be at some point or have been in the past where you need to provide access to your internal resources to semi-vetted, semi-trustable external third parties. And that puts your network and security team in a very sort of impossible balancing act. They need to figure out how to get users a good user experience, administrators something reasonable to handle, and all while they're doing this in a secure fashion. What organizations have done in the past historically is they've just taken those users, those third-party users, and put them right on the normal full-time employee VPN and tried to make it good with policy changes. But this doesn't work out as well as it seems like it should. For one, because those contractors have different needs and different security profiles or risk profiles, what we end up finding out is those contractors, they may have incomplete access, broken access, a number of things that need to get fixed. That takes time and costs money. Now, bigger businesses that I've worked with have tried to get around this problem by shipping laptops. And while that sounds good on paper, one, it's expensive. It's expensive to acquire those laptops. It's also expensive to provision them and ship them and recover them. And it turns out a lot of these laptops are not recoverable. They just walk off, never to be seen or heard from again. But for the sake of argument, let's just say we have this problem solved and we're going to start the journey over to the application. So the VPN client has to cross over the open internet, go to the firewall, where it ends up going into the VPN concentrator and goes ahead and it gets authenticated. Once at this VPN concentrator, again, which has that IP out on the internet, it has an open port so that it can hear a legitimate client coming in. It then weaves its way down through the security infrastructure. And there's a few of them up here I can see I have written up: DDoS, NAC, IPS, what have you. And once it's made it through this backstop firewall, now it can get to whatever app it needs to. And what we found in most organizations, that their apps are spread across and they have pretty permissive rules for how to get there. Now, because this VPN client is making a network level connection, not app, but network level, the user is really deposited on a network. And if your security and network administrators haven't done a very good, diligent job of walling all the things off that VPN user is not supposed to get to, there's a lot of potential for lateral recon, lateral attack, lateral amplification. All right, now with VPN in mind, let's switch it up and let's look at how we would do things with SSE using ztna or Zero Trust Network Access. Again, everything starts off here with the user. Except now the user doesn't need to download any complicated software. They can just use the built-in web browser. Makes their life very simple. It's very easy to find. They're very familiar with this. And when they connect, they actually will connect to this very large, robust global SSE network. They authenticate SAML-based IDP, MFA if that's what's needed, and the SSE cloud begins processing them. Now, what had happened at some point before is on the business side, the business has deployed SSE connectors. And these SSE connectors are deployed near the applications that they need to be connected to. And these connectors will also make a connection from the inside out. So the key point here is business connects to the SSE cloud, user connects to the SSE cloud, they meet in the middle, and that SSE cloud is the one that brokers all of the connections and keeps track of what's going on. Now, right away, you can see there's a pretty major shift in the security here. First, for the external attack surface, there almost is no attack surface here, right? Because these are inside out connections. There's no open port. There's no public IP that is out there listening. It's very difficult to attack what doesn't exist, really. An internal attack surface, again, same type of story. users coming in on a browser which is inherently much less capable. It offers far fewer lateral attack vectors. It goes through this SSE proxy cloud, which is making a proxy or an application level connection. To get into here, it has to still go through these connectors. So every step, what the user can do gets narrower and narrower. These applications, they're not even available to this user unless they are presented and configured in this cloud. That's a zero trust principle, positive security model. Now, beyond those sort of two comparisons, there's a couple other major advantages that the SSE cloud offers. The first one is continuous enforcement. So what continuous enforcement offers you is the ability to, at any moment, modify or end a connection. As an example, let's say the user has been terminated and they've been removed from the IDP. Once they've been removed from the IDP, the SSE cloud learns about it and they can midstream disconnect that user. You don't have to wait for the next login to be denied. Right then and there, it's done. The other area that you could see in terms of continuous monitoring and continuous authorization is, for example, with DLP. So DLP, you change the policy. Maybe you need to make it more stringent, or certain files or keywords are now of concern. It can be applied almost immediately in line. You don't have to wait for a new push. It's done in the cloud immediately. So looking at these two solutions, once again, ztna versus VPN, I think you can see what would be an impossible balancing act in this VPN world is actually pretty straightforward in the SSE world. You can have something that's easy to manage, offers a great user experience, and is actually much more secure. Thanks for watching, and for more information, please come visit our website.